Hi everybody, this video is going to talk about systems of linear inequalities. Now, the previous video talked about linear inequalities where we just had a single linear inequality. With systems of linear inequalities, we're going to have two or more that are graphed together. Now, before we said with linear inequalities that the solutions were found in the shaded region. So remember, we had a solid or a dashed line, we shaded above or below that line. Now we have two of these things. So we're going to have solutions where the two shaded regions overlap. So we're going to be looking at that overlapping region, and because we're looking at points in the overlapping shaded region, the points found in this area are actually points that satisfy not just one of the inequalities, but both of the linear inequalities in our system. So we're going to graph these the same way that we learned how to in the previous video. We're going to look at the inequality symbol and figure out if it's a solid or a dashed line, if we're shading above or below that line. Also keep in mind that our inequalities have to be in slope-intercept form in order for us to actually graph them. So I'm going to color code here. See, we're going to do green and blue. So the first one, I'm going to make a note. I've got, oh, wrong color. But anyway, we have the greater than symbol. And if it's strictly greater than, that tells us it's going to be a dashed line. And we're going to shade above. The less than symbol tells us that it's, again, a dashed line, but we're going to shade below since it's less than. All right, so the green one has a y-intercept at -1, a slope of -1. So we plot our points. And since it's less than, we said when we connect, it's going to be a dashed line. So let's see here. So here's our dashed line, and we need to shade above it. So shading above is going to be up here. Remember in the last video I said think about it as if you were standing on a hill. Above would be the part where you stand, and below would be underneath your feet. So in this case, above would be here. So that's why we're shading where we're shading. Now for our second inequality, we have a y-intercept at -5. And we have a slope of +1 this time. So we're going up 1, right 1. And yes, our lines just intersected, but we're not specifically looking at the intersection points. We're looking at the overlapping shaded region created by these two inequalities. So we had a dashed line again, and we're shading below this line. Now, where are these overlapping regions intersect, or where they overlap, I should say, where the green and the blue cross each other? It'll be right here. And no, it's not very pretty, but you get the idea. Okay, this is where those shaded regions overlap. So if I wanted to find a solution to this system, I'm going to be pulling points out of that shaded red region. So let's pick a couple points here. Let's see, like this would be a solution. Down here would be a solution. This point here would be a solution. And these are the points that satisfy both of those inequalities. So let's take this point as an example. This would be the ordered pair 4, -2. If I substitute the x and the y value here into my original inequalities, we're going to see that it makes both of those inequalities true. So for our top one, we would get -2 is greater than -4 minus 1. Well, that's true because -2 is greater than -5. So that one checks out. When we substitute those values into the second, we get -2 is less than 4 minus 5. Okay, well, -2 is less than 4 minus 5 because 4 minus 5 is -1, and -2 is smaller than that. So this inequality checks out as well. So that point in that shaded region satisfies, it makes both of those inequalities true, and that's why we call it a solution. So this is what we're looking for every time we graph these systems of inequalities. Okay, let's look at another one here. So again, I'm going to color code. And we're going to take a look before we even start at whether it's going to be solid or dashed and if we're shading above or below. So less than symbol. It's going to be a dashed line. And we're going to shade below. So we have a y-intercept up at 7. The slope here is 1/3, so up 1, right 3. And then we got to start backtracking here. Okay, and we're doing a dashed line. Okay, now we said we're shading below. Okay, so here's below. And we're going to graph our second one, but we have a greater than or equal to sign, so our line is going to be solid, and we're going to shade above. So we have a y-intercept at +4. We have a slope of -1. So we're going down 1, right 1. Okay, and then we can backtrack, go up 1, and left 1. Okay, and this time we said it's a solid line. And we said we're shading above. So the overlapping shaded region is right in here. Now, here's the thing. We said last time that, we're looking for solutions. We're looking for points in this overlapping shaded region. So any point that falls in this red shaded area. But now that we have a solid line, what about those points? Because last time we said a point on the line would satisfy the inequality. So let's check here. Let's see if this point, the solid line, will be a solution to the system. So let's see, that is the ordered pair 2, 2, and we're going to substitute that into both of our inequalities, and we're going to see what happens here. So if we plug that into our top inequality, we get 2 is less than 1/3 times 2 plus 7. Okay, well, that would be 2 is less than 2/3 plus 7, which is going to give us 7 and 2/3. Okay, so that's definitely true. 2 is less than 7 and 2/3. So let's plug it into our second inequality. We would get 2 is greater than or equal to -2 plus 4. Okay, well, that's also true because -2 plus 4 is 2, and 2 isn't greater than 2, but it is equal to 2. So this would also be true. So not only do the points in the shaded region satisfy both inequalities, but a point on this solid line will satisfy both inequalities as well. Now, I should clarify, because only the part of this blue line that borders that red shaded region, only the points on this section will actually be solutions. I have another part of this blue line up here. I'm going to circle it, and I know I'm making a mess, and I apologize. The points up here aren't going to satisfy both of these inequalities. Only the points on the solid line that border the shaded region can be included in your solution set. So you have to be careful. So what if we had one where it's not in slope-intercept form? Well, we got to get it in slope-intercept form, just like we did last time. Our top inequality is jumbled up. We need to get y by itself, so I'm going to do some work down here. To get y by itself, we need to subtract x from both sides first. So -x plus 24. And then we're dividing both sides by -4. But you got to remember, when we are dividing by a negative number with inequalities, we have to flip that symbol. -1x divided by -4 turns into +1/4 x. And 24 divided by -4 gives us a -6. So now we have an inequality ready to graph. It's going to be a solid line because we have the equal to part in our inequality. and we're going to shade above because it's greater than or equal to. So now this one is ready to graph. We've got our second one. It's going to be a solid line, and we're going to shade below since it's less than or equal to. So let's graph. So our green one first, we have a y-intercept down at -6 and a slope of positive 1/4. Okay, solid line, so we're connecting here. And our blue one, we have, let's see, a y-intercept at +1 and a slope of 2. So up 2, right 1. And we can backtrack, go down to left 1. Again, solid line. Now, I haven't shaded yet. I want to show you a different idea here because sometimes you get really messy when we have all this shading happening. So the way I like to think about it and do it is I like to graph each of them and then just think about where the overlapping shaded region is going to land, if you want to think about it that way. So we know that we're supposed to be shading above our green line and below our blue line. Well, if we think about it like this, above my green line and below my blue line, the only places where they're going to overlap are going to be right here in this area. And doing it this way makes it a lot less messy. It makes it a lot easier to figure out where on earth we're actually supposed to be shading. And it makes it easier to figure out what our solutions will be. So now we can pick any point inside of this shaded red area. But also, since we have solid lines that border the shaded region, I could pick any points on my solid line as long as it borders this red area. So it would stop here, and then I could start picking up any value along this green line here. As long as it's part of those solid lines that border the shaded region, I can also use those points as solutions. I hope this video helped. Please feel free to ask questions, rewatch, and rewind. Have a great night.